Assalamu alaikum. Welcome to my video series on data science. Today we will explore one more technique in supervised learning, that is classification. In this session, we will explore two simple algorithms, logistic regression and k-nearest neighbors. We will understand their concepts conceptually, numerically, and at the end using a Python code example. Unlike regression, where we predict continuous values, classification is used to predict categories or classes. Classification can be binary class or multi-class. In binary class classification, we can distinguish only two classes. For example, detecting email as spam or not, detecting a brain tumor in brain MRI image. Multi-class classification can predict more than two classes. For example, predicting sentiments as positive, negative, or neutral. Let's talk about logistic regression. Despite the name, logistic regression is actually a classification algorithm. This model works by applying a logistic or sigmoid function to the output of a linear equation. This sigmoid function squashes any input to have value between 0 and 1, which we interpret as probability. If the probability is above 0.5, we classify the input as one class, and if it is below, we classify it as other. Here we have a linear regression equation and a sigmoid or logistic function. A sigmoid function is 1 by 1 plus e raised to the power minus z. And what is z? This is actually the linear regression equation. So if we put the linear regression equation into a sigmoid function, it becomes logistic regression. Let's consider the same example from the previous lecture and convert it into a classification problem. So based on a threshold of $50, we have created a new label that indicates that whether the premium paid by the driver is greater than 50 or not. If it is greater than $50, the class level is 1, and if it is less than $50, the class level is 0. We can see the class distribution on the scatter plot. Instances belong to less than 50 class are displayed using a red color and the other with a blue color. So here are the probabilities and the predicted class after applying logistic regression. If the probability is greater than 0.5, we classify it as positive class or 1, and if it is below 0.5, we classify it negative class or 0. This plot shows the sigmoid curve of a logistic regression model mapping input feature values to probabilities between 0 and 1. Now let's implement it in Python. We will use the same example from the previous lecture where we had mid and final exam score of the students. We will convert the final marks into a discrete class label using a threshold of 60. If the marks are greater than 60, we'll call it class 1, and if the marks are less than 60, we will call it class 0. So now we have converted this regression data into classification data. Here you can see that the distribution of classes in a scatter plot. We will split the data into training and testing part. You will create a logistic regression object and fit it with the training data. After the training, we can see the coefficients of this model. We will record the predictions of the model on the testing data. We calculated the accuracy for the training as well as testing data. We can see that the training accuracy is 85% and the testing accuracy is 80%. We will learn more about the evaluation metrics in the upcoming lectures. kNN or k-nearest neighbors is one of the simplest and most intuitive classification algorithms. It classifies the data points based on their proximity to other labeled data points. It works by finding the k closest data points called neighbors to a given query point and assigns the class label that is most common among these neighbors. For example, if we set k equal to 5, the algorithm will look at the 5 nearest points, and if the majority belongs to a certain class, it will classify the query point as that class. Let's break down how kNN works step by step. Number 1. Choose the number of neighbors. Number 2. Calculate the distance between the query point and all other data points in the dataset. Number 3. Identify the k nearest neighbors based on the distance. Number 4. Assign the query point to the majority class among the k nearest neighbors. Let's understand this with an example. So we have a dataset that contains two features, driving experience and monthly auto insurance premium. And we have a class label that is either 0 or 1. Here is the scatter plot of example data. Each point represents a data instance with colors indicating their respective classes. Now let's introduce a new point called query point, that is 10, 55. This is the point we want to classify. We set k equal to 3, meaning we will look at the 3 nearest neighbor to classify the query point. The distance between the points is calculated using distance matrix. Two common matrices are Euclidean distance and Manhattan distance. In this example, we will use Manhattan distance. Here is a table representing the distance between the query point and all other data points. From the table, 3 nearest neighbors to the query point are 1250, 656 and 1660. Out of these 3, the majority class is greater than 50. Therefore, the query point has been classified as this class. Here is the updated scatter plot with the query point classified as greater than 50 shown in blue. Let's discuss advantages and challenges with logistic regression. It is simple to implement and interpret. It works well for linearly separable data. It is computationally efficient and effective for small to medium-sized datasets. Limitations. Logistic regression assumes a linear decision boundary, which may not be suitable for complex non-linear relationship between the features and the target variable. Outliers can significantly impact the model's performance, especially when the dataset is small. Let's talk about advantages of kNN. It is a non-parametric and does not assume any specific data distribution. It can capture complex decision boundaries for classification tasks. Limitations. It is computationally expensive, especially for the large datasets due to distance calculation for every query point. Its performance depends heavily on the choice of K and the distance metric. If you found this video helpful, don't forget to like, share and subscribe for more videos on data science and AI. See you next time.